Hi guys, it's Victor, and this is a solution for the problem Codeforces 1436b prime square. This is a rather simple division 2 problem, however, it requires some insight. We rate the complexity of this problem as 2 out of 5, and its elegance as 4.5 out of 5. As always, please take a minute and read the problem statement yourself by the link in the description for this video. Cool, let me rephrase the statement now. You are given an empty square matrix with its size n by n. Please fill it with numbers so that there are no prime numbers in the matrix, and the sum of numbers for every row and every column is a prime number. Here are the examples from the problem statement. This is a prime matrix. As you can see, the sums for every row and every column equals 2, which is a prime number. Please also note that 1 is not a prime number. It is important for our solution. This is another example of a prime matrix. Here, the sums for every row and every column are prime numbers, and none of the numbers in this matrix are prime. So your goal is to fill a matrix with numbers this way for its given dimensions. Let's take a pause and think of a possible solution. At first, it is completely unclear how to tackle this problem. Is it a dynamic programming problem? Is it a linear algebra problem? Does it involve any number theory? The elegance of this problem is that it is unclear how to start with its solution. There are many solutions to this problem, and all of these based on some key insight. Let's try to combine all the data that we have now. The matrix can be flipped by any dimension. Indeed, it will change only the order of sums, but not the values. There is possibly an infinite number of solutions. For the particular statement, however, they will be limited by the problem constraints. We can return any solution, and as the matrix can be flipped, the direction of the rows and columns doesn't matter. That's why the solution can be somewhat symmetrical. Great. Now let's try to brainstorm and come up with any additional observation. Let's say we have a matrix 2 by 2, as in our example. The first thought is to fill it with ones. And it's an answer already. Let's inspect a matrix 3 by 3. What shall we do here? Fill with ones, of course. And we have an answer again. Now let's move further and increase the size. We try to fill it with ones, but unfortunately, unsuccessfully. We need to decrease every row and every column by some number. For example, by 1 to get 3. A naive thought is to introduce a zero-filled column and a zero-filled row. This will work for the matrix except for the zero-filled rows and columns. Is there a way to decrease every row and every column by 1? Let's take a minute here. It's the first key to the solution. We can decrease every row and every column in the matrix by some number, subtracting that number from the matrix diagonal. The matrix 5 by 5 will work with ones in every row and every column again. Please also think of the matrices 6 by 6, 7 by 7 and 8 by 8 yourself. Now we have a matrix 9 by 9, and here we have a problem. If we subtract 1 from any diagonal, we will not get a prime matrix, as 8 is not a prime number. If we only had a way to subtract more than 1, as the numbers are non-negative, we can do so only by adding additional zeros to the matrix. Let's try to find a position for additional zeros. This will work for all the rows and all the columns, except the essential ones. Now think how we can decrease the sum for every column and every row in this matrix by 1. This is the second key to the solution. One of the ways of doing so is to add an additional diagonal of zeros below the initial one. Did it decrease the sums for all the rows and columns by 1? Yes, except for these. How can we additionally decrease the sums for the given row and column? By adding an additional 0. And this looks pretty generic. Now, as you can see, we can extract two numbers from every row and every column. We can base our solution on this logic so far, but let's make an important observation. Instead of filling the matrix with the same numbers and extracting two other numbers from every row and every column, we can fill the matrix with zeros and only add two numbers into every row and column. This will be essentially the same, and A and B can remain the same regardless of the size of the matrix. Now let's select A and B so that they are not prime and A plus B is a prime number. My proposal is to make A1 and B1. Then for every matrix, the pattern as here will be a solution. And let's look at the possible source code. Look at the elegance of the final solution. The complexity of the source code is linear to the size of the source matrix and the output. Please note that the size of the matrix is n by n, not n. The solution is available as a GitHub link to the description for this video. Please subscribe to see analysis of other interesting programming problems, and please grow as a developer harder, faster, better, and stronger. Stay tuned.